Welcome everyone. I'm excited to kick off today's presentation on real-world IT. Today, we'll be focusing on Windows troubleshooting methodology, and you'll see that I've included commands on every slide to help reinforce the concepts. We'll start with an overview of how to approach common issues, and I'll guide you through practical steps to resolve them efficiently. Let's get started and explore how to become more confident in troubleshooting Windows problems. Let's start by understanding why it's so crucial to identify the correct problem before jumping into solutions. When we focus on the wrong problem, we end up applying the wrong fix, which can make things worse rather than better. This is why taking the time to clearly define the problem is so important. The impact of not doing this can be significant. Think extended outages or wasted effort that could have been avoided. These are costly and frustrating for everyone involved. So, how do we ensure we're tackling the right issue? We need a clear approach. Ask who is involved, what is actually happening when it occurred, and where it's happening. These questions help us gather the right context. Additionally, using simple commands like getDate and whoami can quickly give us essential information about the system and user context, helping us validate our scope before making any changes. Ultimately, the key is to define the problem properly before taking action. This step ensures we're addressing the root cause, not just symptoms, and sets us up for a successful resolution. Let's start by understanding why it's crucial to identify which users or systems are affected. Knowing the scope helps us focus our efforts where they're needed most. Once we have that clarity, we can determine the impact, which guides how we prioritize and contain the issue effectively. Next, we want to check our monitoring tools and tickets to gather real-time information. For instance, running the command getComputerInfo select CS name allows us to quickly identify the affected systems by their names. This step is essential to get a clear picture of the situation. After collecting the data, we need to decide whether we're dealing with a single system or a widespread problem. This decision influences our response strategy, whether to isolate a single device or to implement broader measures. Finally, all of this ties back to determining the scope and impact. Understanding the extent of the issue helps us plan the most effective response, ensuring we're addressing the right systems and minimizing disruption. Remember, thorough assessment at this stage sets the foundation for a successful resolution. Why is reviewing logs so important? Well, logs reveal the root causes of issues, helping us understand what's really going on under the hood. By analyzing these logs, we can identify the underlying problems more accurately. The impact of doing this is significant. Faster diagnosis means we can resolve issues more quickly and get systems back up and running smoothly. So, how do we approach this? The key is to review the system logs regularly. For example, you can use the command getWinEventLogNameSystem maxEvents50 to pull the most recent 50 events from the system log. When reviewing these logs, focus on error and critical events. They're usually the clues pointing to what went wrong. Always check the system event logs thoroughly because they contain essential information that guides troubleshooting. Remember, paying close attention to these details helps us pinpoint root causes faster and more effectively. Let's talk about why we focus on app failures here. This is where all the logs related to application issues are stored, making it a critical starting point for troubleshooting. The impact of these failures can be significant, often leading to service or application outages that affect users and business operations. So, how do we approach this? The key is to review the application logs carefully. Using the command getWinEventLogNameApplication maxEvents50, we can quickly retrieve the most recent 50 entries from the application log. It's important to correlate timestamps from these logs to identify patterns or specific events that might indicate the root cause of the failure. Additionally, checking the application event logs thoroughly helps us piece together what happened around the time of the outage. By connecting these dots, we can better understand the issue and work towards a resolution, ensuring our services stay reliable and available. So let's talk about why most issues tend to follow changes. Essentially, whenever we implement a change, whether it's a patch or a configuration tweak, there's always a chance it can introduce unforeseen problems. That's why understanding this relationship is crucial. Now, in terms of impact, one of the quickest ways to address these issues is by performing a rollback. If we identify that a recent change caused the problem, rolling back that change can often resolve the issue swiftly and minimize downtime. Moving on to how we approach this practically, reviewing patches and configurations regularly is key. For example, you can use commands like get-hotfix and sort the results by the installation date to see what's been recently applied. This helps you pinpoint recent changes that might be the culprit. It's also important to check deployments and GPO changes. Changes in group policies or deployment processes can often be the source of issues, especially if they've been recently modified. Lastly, always correlate recent changes with the issues you're experiencing. By aligning what was changed with what's not working, you can more accurately identify the root cause and address it effectively. Remember, understanding the connection between changes and issues is a central theme in maintaining system stability and performance. So let's talk about why high CPU usage really matters. When the CPU is running at its maximum, it can cause the system to slow down significantly. This is because the processor is overburdened and can't handle all tasks efficiently. The impact of this is quite noticeable. Users will experience degraded performance, which can lead to frustration and decreased productivity. It's crucial to keep an eye on this because slow response times affect the overall user experience. Now, how do we address this? The first step is to identify the top processes that are consuming the most CPU resources. A simple way to do this is by running a command like getProcess, then sorting the results by CPU usage in descending order, and selecting the top 10 processes. This helps us pinpoint which processes are the biggest culprits. Once we have that information, we need to confirm whether the high CPU usage is a sustained issue or just a spike. Is it a consistent problem or a temporary blip? Checking the CPU utilization over time helps us make that distinction. By monitoring and analyzing CPU utilization regularly, we can better understand the patterns and take appropriate action. This approach ensures we're addressing the root cause rather than just the symptoms, ultimately maintaining a smoother and more responsive system for everyone. Why is this important? Well, memory pressure can lead to crashes, and nobody wants their application to fail unexpectedly. When the system runs low on memory, it often causes applications to become unstable or even crash completely. That's why understanding and managing memory usage is critical for stability and reliability. The impact of not monitoring memory closely is quite significant. Application failures can disrupt user experience, cause data loss, and impact overall system performance. So, we need to be proactive in preventing these issues before they happen. Now, how do we do that? A good starting point is reviewing the application's working set. This tells us how much memory a process is actively using at any given time. To do this efficiently, we can run a simple PowerShell command, getProcess, then sort the processes by their working set size in descending order, and select the top 10. This helps us quickly identify which processes are consuming the most memory. But remember, it's not just about the current numbers. Watch out for memory leaks, those sneaky issues where memory usage keeps growing without being released. Regularly checking memory usage patterns can help us spot these leaks early. Ultimately, keeping an eye on memory usage is essential for maintaining application health. By reviewing working sets, watching for leaks, and understanding how memory is allocated, we can better prevent crashes and ensure a smoother experience for users. Let's talk about why low disk space can be a serious issue. When disk space runs low, it can break services, meaning some functionalities might stop working properly. This can lead to bigger problems, like application failures or even operating system crashes. So, what's the impact? Essentially, if your disk is nearly full, applications and the OS itself can fail, causing downtime and potential data loss. That's why it's crucial to keep an eye on free space. Now, how do we prevent this? The key step is to review the available free space regularly. One way to do that is by using the command get ps drive with the file system provider. This command will show you how much space is free and used on your drives. When checking disk space, a good rule of thumb is to look for less than 15% free. If your free space drops below this threshold, it's time to take action to free up some space. Remember, regularly checking disk space is a vital part of maintaining healthy systems and ensuring smooth application and OS performance. Let's talk about why disk errors are a serious concern. Essentially, they can corrupt your data, which can lead to a lot of problems down the line. When data gets corrupted, it might cause your system to lose important files or even crash unexpectedly. That's why it's crucial to regularly review your disk status. One effective way to do this is by running the command chkdsk scan. This tool scans your disk for errors and helps identify issues early before they cause bigger problems. Additionally, if your system supports smart or self-monitoring, analysis, and reporting technology, make sure to check it. Smart provides valuable insights into the health of your disk, giving you a heads up if it's starting to fail. Finally, always verify the overall health of your disk. Keeping an eye on these indicators can save you from unexpected data loss and system crashes, helping to keep your data safe and your system running smoothly. Now, let's talk about why understanding network issues is so crucial. Often, network problems can mimic app failures, making it tricky to pinpoint the real cause. Recognizing this helps us avoid unnecessary troubleshooting steps. The impact of these issues can be significant, leading to service outages that affect user experience and productivity. So, how do we address this? The key is to test connectivity and ports effectively. For example, using the command testnet connection followed by the server name and specifying the port, such as 443, which is commonly used for secure web traffic. This helps us verify if the server is reachable and if the port is open. But connectivity isn't just about pinging the server. We also need to verify DNS resolution, making sure the domain name correctly translates to the right IP address. Additionally, validating network connectivity overall ensures there are no underlying issues blocking communication. By systematically testing these aspects, we can quickly identify whether network problems are causing the app failures, allowing us to focus our troubleshooting efforts more effectively. This approach ties directly into our broader goal of maintaining reliable and resilient services. Let's talk about why DNS failures are such a critical issue. When DNS fails, it can break authentication processes and disrupt application functionality, which can be a major headache for your entire system. The impact of these failures can be widespread, affecting multiple services and users, so it's essential to address them quickly. So, how do we prevent or troubleshoot this? The key is to validate name resolution. You want to make sure that your DNS is resolving names correctly and that your systems can communicate with the DNS servers without issues. A useful command to help with this is resolve DNS name, followed by your server name. This allows you to check if the DNS can resolve that server name properly. In addition, it's important to verify the availability of your DNS server itself. Ensure it's up and running. Lastly, always check DNS resolution to confirm that queries are returning expected results. By systematically validating these areas, you can quickly pinpoint where the problem lies and restore normal operations efficiently. So, why is this important? Well, services can stop unexpectedly, and that can cause some serious issues. When a service stops, it often leads to application downtime, which can disrupt operations and affect users. That's why it's crucial to be able to identify these stopped services quickly and effectively. To do that, we can use a simple command, get service, which lists all services, and then pipe it through a filter to find those that are not currently running. Specifically, we look for services with a status not equal to running. This helps us pinpoint exactly which services have stopped. Once we've identified a stopped service, The next step is to restart it, but only if it's safe to do so. Restarting a service without checking can sometimes cause more issues, so always verify that it's okay to restart. After restarting, it's essential to verify the service status again to make sure it's running properly. This process is a key part of maintaining system reliability and ensuring minimal downtime, which ties back into the overall goal of keeping our applications up and running smoothly. So one common reason why users might experience access issues is due to firewalls or group policy objects, or GPOs, blocking their access. This can lead to user lockouts, which can be frustrating and disruptive. To troubleshoot this effectively, the first step is to check the applied policies on the affected machine. You can do this easily by running the command gpresult hrsop html, which generates a report showing all the policies that are currently enforced. Next, it's important to review the firewall logs carefully. These logs can reveal if any firewall rules are blocking specific traffic or ports necessary for user access. Additionally, reviewing security controls in place helps ensure there aren't any restrictions that might be unintentionally hindering user connectivity. Connecting all these points, understanding how policies and security configurations impact access is crucial in the overall security management. By systematically checking the applied policies, examining firewall logs, and reviewing security controls, we can pinpoint the root cause of these lockouts and resolve them more efficiently. So, one important thing to keep in mind is that even well-intentioned fixes can sometimes introduce new issues. That's why it's crucial to be cautious when making changes. We need to consider the potential impact, such as change-induced outages, which can temporarily disrupt services or cause unexpected problems. To minimize these risks, the best approach is to apply only the minimal necessary change. This helps reduce the chance of unintended side effects. When you're ready to implement the fix, you can use the command restart service followed by the service name to restart the service safely. Remember, it's also vital to document all actions taken during this process. Keeping a clear record helps in troubleshooting if something doesn't go as planned later on. Finally, always apply fixes carefully. Think through each step and verify everything before proceeding. This careful approach ensures we maintain stability while making necessary updates. So, why is this step important? Ensuring the issue is truly resolved is crucial to prevent it from causing more problems down the line. The impact of doing this properly is that we can prevent repeat incidents, saving us time and resources in the long run. Now, how do we do this? The key here is to retest the original failure. That means running the same steps or commands that previously caused the issue to see if everything is working as it should. The command part is simple. Repeat the failing command or application. This helps us verify that the problem no longer exists. Next, we want to confirm that logs are clean, meaning there are no new errors or warnings related to this issue. Clean logs are a good indicator that the problem has been effectively resolved. Finally, always verify the resolution. Double-check that everything is functioning correctly and that the fix sticks. By following these steps, we close the loop on our troubleshooting process, making sure the issue is genuinely behind us and won't recur. Now, let's talk about why it's important to monitor logs even after we've applied a fix. Sometimes, issues can recur if we don't keep an eye on the system, so continuous monitoring helps us catch any signs of the problem coming back early. The impact of doing this is that we can respond more quickly in the future. By staying vigilant, we reduce downtime and improve overall system stability. So, how do we do this? The key is to monitor logs after implementing a fix. For example, we can run the command getWinEvent with a limit of 20 events to review recent activity and see if any new issues are cropping up. It's also essential to update our knowledge base and runbooks regularly. This way, we keep our documentation current and ensure everyone knows the latest procedures. Finally, we should continuously monitor and document what we find. Keeping good records helps us track patterns over time and improves our response strategies. Remember, Ongoing vigilance is a critical part of maintaining a healthy system and preventing issues from escalating again.